Today, we'll dive deeper into the world of gears by exploring the different types of gears. Gears are found in everyday applications, from wall clocks to car steering systems. In today's video, we will explore different types of gears, their unique characteristics, and how they are used in everyday applications. Spur gears are the simplest type of gear, with straight teeth that are parallel to the axis of the gear. They transfer power and motion between parallel shafts. The main advantages of spur gears are their simple design, low cost, high precision, and low maintenance. They are commonly found in many everyday devices. For example, in a clock, spur gears play a crucial role in precisely controlling the movement of the hands, ensuring accurate timekeeping. The gears mesh together to transfer motion from one gear to the next, each step driving a specific function within the clock mechanism. Similarly, in wind-up toys, spur gears convert the stored energy from winding into controlled motion, making the toy move. Spur gears are also widely used in other applications, including gear pumps, sliding mesh gearboxes, watches, sugarcane crushers, printers, conveyor systems, wind turbines, and elevators. The disadvantages of spur gears are that they can produce noise and vibration at high speeds. Helical gears overcome the disadvantages of spur gears by operating more smoothly and quietly. Helical gears are similar to spur gears but have teeth that are inclined at an angle, known as the helix angle. This design allows helical gears to transfer power and motion more smoothly and quietly than spur gears. In a helical gear pair, one gear may be a left-hand helical gear, while the other is a right-hand helical gear. Helical gears are chosen for their ability to handle higher loads quietly and efficiently, making them ideal for a wide range of machines and devices. Here's a question. Typically, a helical gear pair consists of one right-hand and one left-hand helical gear. But can we use helical gears with the same hand? Yes, a screw gear system uses two helical gears with the same hand to transmit motion. However, these gears must be set at a specific angle. They are designed for non-parallel, non-intersecting shafts, usually at a 90-degree angle to each other. Double helical gears look like two helical gears placed side by side but with opposite helix angles. This design balances out the thrust forces, eliminating axial load on the bearings. Double helical gears are known for their high power transmission capacity and smooth operation, but they are expensive to manufacture. Spur and helical gears are limited to transmitting power in parallel configurations. In cases where power transmission is needed between intersecting axes, bevel gears are employed to achieve this. Bevel gears can transmit motion at a 90-degree angle or other angles, making them useful in a variety of situations. There are several types of bevel gears. Straight bevel gears are the standard for bevel gears. They have a conical pitch surface, but the teeth are straight. Spiral bevel gears have curved teeth, which provide higher efficiency, strength, and reduced noise compared to straight bevel gears. However, they are more difficult to produce. The angle between the tooth trace and an element of the pitch cone is called the spiral angle of a bevel gear. When the spiral angle of the teeth is zero, it is called a zero bevel gear. You can clearly see the difference in the curves of both types of gears, as zero bevel gears have a unique combination of straight and curved teeth. A hyphoid is a special type of spiral bevel gear, where the shafts of the two gears don't meet. Instead of the gear's axes intersecting, the smaller gear's shaft is offset from the larger gear's shaft. These are straight bevel gears. When both gears have the same number of teeth, the bevel gear ratio is 1:1. This type of gear is called a mitter gear. Mitter gears are used to change the direction of power transmission without changing the speed. Types of mitter gears include straight mitter gears and spiral mitter gears. Here, you can see the gear with its straight teeth extending outward from the edge, resembling a crown. This type of gear is called a crown gear. Notice how the teeth are perpendicular to the gear face. Worm gears consist of a screw-like worm and a worm wheel. They are used to transmit power between non-parallel, non-intersecting shafts. Worm gears are known for their high reduction ratios and smooth, quiet operation. However, they are less efficient due to sliding contact and are more expensive to manufacture. You can find worm gears in steering mechanisms. Take a hand mixer, for example. Inside, a worm gear system provides a significant reduction in speed while increasing torque, ensuring the beaters rotate with enough force to mix ingredients efficiently. This is a rack and pinion gear system. This part is called the rack, and this is the pinion. The pinion gear meshes with the rack, converting rotational motion into linear motion. Let's see an example. This is the steering system of a car. You can see how the rotational motion is transferred into linear motion to turn the wheels. This is a spur gear. When multiple spur gears are connected in a sequence, they form what is known as a spur gear train, which can be used to reduce speed in mechanical systems. When two or more gears are mounted on the same shaft, it is called a compound gear. When multiple compound gears are arranged in a system, it is called a compound gear train. It allows the gears to rotate together, providing the ability to transmit different speeds or torques throughout the system. In this gear train system, this is the input shaft, and this is the output shaft. Here, the output shaft shares the same axis as the input shaft. This type of gear train is called a reverted gear train. Here, this is an epicyclic gear train, or planetary gear system. At the center, this is called the sun gear. Around it, these are the planet gears, which rotate and revolve around the sun gear. The planet gears mesh with the outer ring gear, also known as the internal gear. This type of gear train is very efficient and is often used in automatic transmissions of cars due to its compact design and high efficiency. In upcoming episodes,